Friends, welcome you in Research Needs. In this video, we will see physiological salt solution used in experimental pharmacology. So we will see here how to prepare them and what is their uses. So we will go with the Expharma software. So here we will click. Here you can see the interface. Here it's showing visual modules, physiological salt solution used in experimental pharmacology. So we will click this and start the experiment. Now here we will see first about the physiological salt solution by listening. I am clicking this.
About physiological salt solution. Physiological salt solution is artificially prepared solution used to maintain various tissues under viable state. It is used to keep isolated tissue alive under experimental conditions. It helps to maintain tissue outside the body and fulfill their internal environment of ions and nutrients. It is a solution of salt or salts that is essentially isotonic with tissue fluid or blood. The salt helps to maintain the isotonicity, isomolarity, contractility and excitability of the tissue. We need different physiological salt solution for different tissue or organ.
Now we will see next one, the requirement. What is the requirement to prepare these solutions for apparatus, what apparatus we needed, what chemicals we needed, we will see here.
Requirements: apparatus, weighing balance, beaker, stirrer, spatula, butter paper. Chemicals: sodium chloride, potassium chloride, calcium chloride, sodium bicarbonate, sodium hydrogen phosphate, potassium dihydrogen phosphate, glucose, distilled water.
So this was the requirement. Next we will see the standard table. We will go in detail.
Standard table. Composition: sodium chloride. Frog ringer 6.2. Frog lock 9.0. De Jallo 9.0. Crepe 6.9. Function: to provide isotonicity, isomolarity, contractility and excitability. Composition: potassium chloride. Frog ringer 0.14. Frog lock 0.42. De Jallo 0.42. Crepe 0.35. Function: to provide ionic balance. Composition: calcium chloride. Frog ringer 0.12. Frog lock 0.24. De Jallo 0.06. Crepe 0.28. Function: to provide contractility. Composition: magnesium sulfate. Frog ringer 0. Frog luck 0. De Jallo 0. Crepe 0.28. Function: to stabilize the preparation. Composition: sodium bicarbonate. Frog ringer 0.2. Frog lock 0.5. De Jallo 0.5. Crepe 2.1. Function: to provide alkaline medium. Composition: sodium hydrogen phosphate. Frog ringer 0.008. Frog luck 0. De Jallo 0. Crepe 0. Function: as a buffer. Composition: potassium dihydrogen phosphate. Frog ringer 0. Frog luck 0. De Jallo 0. Crepe 0.16. Function: as a buffer. Composition: glucose. Frog ringer 2.0. Frog lock 2.0. De Jallo 0.5. Crepe 2.0. Function: to provide energy.
So these were the standard table, and that this chart you can take a screenshot and also you can fix this in your lab. so that you can easily prepare the solution by seeing these compositions. Now we will go for next stepwise procedure how to prepare this.
Stepwise procedure. Weigh all chemicals accurately. Dissolve alkalis and sodium hydrogen phosphate glucose calcium chloride separately in distilled water in beaker. Mix all these solutions. Add the required amount of sodium bicarbonate in sufficient volume of distilled water. Add sodium bicarbonate at the time of setting up of the experiment. Since calcium carbonate is liable to be precipitated if the calcium and bicarbonate are kept long together.
Next we will see uses of this physiological salt solution. Now so we will click this.
Uses of different PSS. Krebs solution used for nerve muscle preparation. Thyroid solution RT can be used for experiments involving mammalian smooth muscles. Ringer solution. It is used for amphibian tissue such as frog's heart. Ringerlock solution used for heart muscle preparation. Degelo solution used for mammalian isolated organs.
So our video is complete. So how was the video? Please do comment. Thank you for watching Research Need. Thank you very much.